So welcome back to another video. In this one we're gonna examine our wing in the flow simulation here in SolidWorks. So this is the wing of Williams we did in the tutorial. I will also probably leave the link for this file so you can use it as well. This is not gonna be something like a tutorial, but if you don't know how to use a SolidWorks Flow Simulation, you should be able to understand and learn because it's easy. I'm using SolidWorks 2016. You should have in previous versions all options I have here. So we go to add-ins and we select flow simulation. Okay, I'm gonna hide this, and for a start we have to go to find this flow simulation tab and go to wizard. So next we select this unit system, next external exclude. Okay, reference axis is gonna be Z because direction of air should be in that axis. Next gases, it's air. Next and we need minus 100, and 100 meters per second is around 300 kilometers per hour. You can see by pressing minus you have this direction of wind, and that's what we want, so finish. Now as you can see, this box is where we should have the air going and hitting the wing and giving us results. So we're gonna just slightly set it up. We go to edit definition. Here we need something like -1, here 2.5, on this one -2.5, and here 2. From the sides we need something like 3.5 and -1.5. Click OK. So like I said, this box is our area where the air is gonna flow around the wing. What else? We need to go here in flow simulation, go to insert global goals and find force X, Y and Z and click on them. Okay, and here X is, as you can see on this axis, is the side force, not so important. Y is important, that axis is the down force, so down force, and Z is drag. Now when we've done all of that, we can go to run. Make sure to have these things selected and use as many cores as you have on your PC. More cores, better PC means will be done faster. I'm gonna use 3 because I have to still record what's happening. Click run, and it's gonna take some time. Not if your PC is decent, it shouldn't take more than 5 minutes. I think on my PC it will take around 2 minutes. As you can see down here, it says it's still preparing the model. Meshing, and it has started. So I'm gonna go to insert goal plot. We're just now taking a look at our forces on the axis, on 3 axes. I have to say also that SolidWorks is not some perfect simulation tool. Flow simulation is just used to check your design and to get approximate values of forces that should come up in the real life, but for some very serious simulations you should use ANSYS or some other professional software. We can see here we have around, on the downforce we have around 3000 newtons. It should be around 300 kilograms. Drag is 1200, which means 120 to 125 kilograms, and side force is only 7 kilos, which is good. Of course we wanna have as highest downforce as we can with lowest possible drag. And 3 hours later it seems it's finally done. As I said, you cannot take these results very seriously, because you saw we needed only 73 iterations to check drag and downforce, and since then we needed more than 200 iterations to get the side force, and it's still not done. So yeah, like I said, use some professional software if you want professional results. Let's close this and hide computational domain. What's important for us is flow, the airflow around this wing. So go here to flow trajectories or find it in the tab. And if you are having decent PC, if it's not slow, you can here have more points. If your PC is slow, then use less than 50. I'm gonna use spheres. You can use something else for this animation of the simulation, and I'm gonna use 0.01. And we need here, of course, to select some faces, and make sure to select these main and big faces, because it may not work if you select the smallest. So this should work. Let's click OK. And this is what you get. So let's just quickly take a look at it before we hit play. It's really interesting to see how air is going around. As you can see, I think that this wing is very well designed. We did a good job. Even this is a replica of the real wing, and it's really simple. A replica, you can see how the air is going to the side, avoiding the front wheel. Maybe not completely, but it's almost there, and that's really good result to see. Also, let's check the nose. You can see the nose there are no red uh, pressure points, which means the nose is also very well done. As you can see here, designers with these fillets, they made a good decision to do it, because if they left the surface flat, the air would go on top here, and it would create additional not needed downforce. But as you can see here, it goes to the side, which is more air efficient, let's call it that way. Here you can see one stream of air is going also below the car, which is not also bad, because you want to have more air on the rear diffuser on the floor. And now let's hit play. So yeah, it's very interesting to see this. Also, here you can see that air is going from the front wing somewhere around here, and if you are really familiar with Formula 1 design, you know that here the car has its how it's called, not side pods. Yeah, I think it's called side pod, where you have the holes for the radiators which are cooling down the engine, so you can see how air is also going in that direction. Here it's very well done. Let's see from the bottom. Yeah, I'm really happy with how this is looking like. It's maybe not perfect, but it's very well done. And also, as you can see, you cannot see anywhere any small vortex of air spinning around, which means we still done a great job modeling this replica of the front wing. I might also do the rear wing in next video, but for this one that was all. Also, let me just say the final thing. In the results you can, here in GoPlot, you can see your forces. Let me just see, where is it? So yeah, drag is 1191 Newton, which is around 120 kilograms of drag. Downforce is around 3000, which means around 300 kilograms. So 300 kilograms of downforce is created when the car is at the speed of 360 kilometers per hour, and some minimum minus, so 10 newtons, that should be 1 kilogram, I think. And yeah, that's pretty much it. Like I said, see ya in some of my next or other videos.